Okay, today we're going to learn how to dilute solutions. So the equation we use to dilute solutions is M1 times V1 equals M2 times V2. M1 just stands for the initial molarity. Okay. A lot of times you're going to see this being called the stock solution. Okay. And that just means we have it in stock. If you think in the back closet where I store all the chemicals, I don't have 20 different concentrations of acid. I just get one stock solution and then dilute it to what we need to. Okay. So if you see stock solution, that's your initial molarity. V1 is your initial volume. M2 is your final or desired molarity, and then V2 is your final volume. And then up here for volumes, I put liters. Milliliters are also fine as long as V1 and V2 are the same unit. Okay, so you can be in liters or milliliters. Okay, we're going to do a couple practice problems together. So our first one is, how would you prepare 100 milliliters of 0.40 molar MgSO4 from a stock solution of 2.0 molar MgSO4? So probably the hardest part of these equations is figuring out which ones are your initials and then which one are your finals. So your hint is if you see stock solution is your initials. Okay, so M1 is going to be the 2.0 molar. And then when we dilute solutions, we need to figure out what volume we have. So we're going to solve for V1. So we're going to say V1 equals question mark. Okay, and then if we look at the problem, we're trying to end up with 100 milliliters of a 0.4 molar solution. Those are going to be our finals. So M2 will be the 0.40 molar, and V2 will be 100 milliliters. Okay, so when we dilute, we'll always use our dilution equation. So M1 V1 equals M2 V2. If we know 3 of the 4 variables, can we just plug those in and solve? Okay, so we're just going to plug in this exact order. So for M1, I'm going to write 2.0 molar. Okay. We're solving for V1, so I'm going to keep it as V1. M2 is 0.40 molar. And V2 is 100 milliliters. So now can we just use algebra to solve for V1? Okay, how do we solve for V1? Good. Okay, so let's divide by the 2 on both sides. So what's 0.4 times 100? 40. What's 40 divided by 2? Okay, so V1 is 20. And then if you look at units, do you see how the molars cancel? So what's the only unit that didn't cancel? Okay, so V1 is 20 milliliters. So what that means is if we're going to make this solution, we need 20 milliliters of the 2.0 molar MgSO4. Okay. And then if you're diluting something, what else are you adding to it? What did you say? Water. Okay. So you're going to take the concentrated chemical and you're going to add water. You need to get to 100 milliliters. 20 of those are going to be this magnesium sulfate. So how much water are you going to add? Good. 80. Okay, so to make this solution, you need 20 mils of the magnesium sulfate and then 80 milliliters of water. Okay, this time you need 250 milliliters of 0.20 molar NaCl, but the only supply you have of NaCl is 1.0 molar. So how much water do you need to dilute the solution from 1 molar to 0.2 molar? Okay, so first we just have to figure out like our initials and our finals. Okay. So initially, what's the concentration of the sodium chloride you currently have? Okay, so that initial, it says the only supply you have is the 1.0 molar. And then we're going to keep solving for V1. So we're going to figure out how much of that we need. So then by the time you're done diluting, what concentration are you trying to get to? Okay, so 0.2 molar is M2. And then what volume of solution do you want? Okay, 250, bless you. Okay, from here, what equation do we use? Good. M1V1 equals M2 V2. Okay, so now we're just going to plug in our numbers in that exact order. Are you all with me so far to this point? Yes. Okay, and then algebraically, what do we do to get V1 by itself? Okay, so let's divide both sides by that 1.0 molar. Okay, what's 0.2 times 250? 50. What's 50 divided by 1? Still 50. And then notice the molars cancel. So what's your unit? Okay. So then this one asks how much water are you adding to dilute it? Is 50 your final answer? Okay. Why isn't 50 your final answer? Okay, it doesn't add up. So the way you'd make that solution, it's 50 milliliters of the 1.0 molar NaCl. And then how much water are you adding to that? 200. Where does the 200 come from? Okay. V1 plus water has to equal V2, correct? Okay. So this time, since we just want to know water, I'm really looking for this one. The last thing we'll talk about today is how can we quantify solutions? So when we want to know how much solute is in a solution, we're going to give it by a percent. Okay, so what percent of a solution is just the solute? So it depends how the solution's made. If it's a liquid mixed in a liquid, we'll express that solute concentration with percent by volume. So think like alcohol. How many of you like rubbing alcohol at home? Okay, all like rubbing alcohol is just like isopropyl alcohol mixed with water. Okay, so then it's given to you in like a form of a percent. Like at home, if you go to the grocery store and you buy your rubbing alcohol, it's usually like 70%. Okay. So then how we calculate percent by volume, we just take the volume of the solute divided by the volume of the solution times 100. The key here, solution is always the total volume. So maybe write yourself a little note. Okay. So total volume, meaning it'll be the solute plus the solvent. Okay. Sometimes you'll get a word problem that kind of like tries to trick you with its wording. Okay, so this time a solution's prepared by dissolving 60 milliliters of ethanol and enough water to make a total volume of 200 mils. What's the percent by volume of ethanol? So when we do the percent volumes, we're just going to take the solute divided by the total solution times 100. Okay. So in this scenario, what's the volume of your solute? Okay, 60 milliliters. What's the volume of the total solution? 200. So divide those and get your fraction and then multiply it by 100. Okay, what are we getting? 30? Okay, do we agree we're getting 30? Okay, so this just means it's 30% alcohol. So then what percent of water is it? 70. Good. Okay, the other way we can represent the percent of solute, let's say you have a solid dissolved in a liquid. Like let's say we're just making salt water. Okay. We represent that with mass by volume. So this one is just the mass of the solute in grams divided by the volume of the total solution in milliliters. And then again, times 100. Okay, so this time, let's say we have a solution. It's prepared by dissolving 20 grams of sodium chloride in enough water that makes a 500 milliliter solution. So we just want to know what's the percent by mass volume of the sodium chloride. Okay, so this one will say percent. I'm just going to say M over V for mass volume. So it's just going to be grams of the solute over milliliters of the solution times 100. So for this mixture, how many grams of solute were put in there? Okay, so we have 20 grams of solutes. What's the total volume of the solution?
500.
Okay, 500 milliliters. So go ahead and divide those and then multiply by 100. Okay, so then we're getting 4%. So that means this solution, it's 4% salt. So then what percent of it is water? Good. So 96% water, 4% salt.